Imagine that in a corner of the world, whether in the heart of the North Pole or on a remote island, there is nothing but vast expanses of snow and ice. However, you need the internet. But in these conditions, you cannot use undersea cables and fiber optics. So what should be done? Well, this is where satellites come into play. This technology, which perhaps should only have been seen in science fiction movies, has now become a reality. But the important question is whether satellites can provide the internet at the same speed in places where cables cannot reach. Before we start our discussion, I wanted to remind you not to forget to like the video, leave a comment, and turn on the notification bell to support our team's efforts. Because it's only with your support that we can provide quality content. Alright, let's get to today's topic. Satellite internet is a wireless internet that is sent to Earth through satellites orbiting the planet. This system is very different from internet services that are transmitted via cables because they use wires to transfer data. Satellite internet is becoming more popular and usable every year. It is also predicted that by 2030, more than 100 million people will use satellite internet. It's important to know that satellites play a particularly crucial role in providing internet in areas where access to conventional communication technology like undersea cables and fiber optics is not possible. These areas can include the poles, forested regions, deserts, rural areas, remote islands, or even places where cheaper internet options are not available. But the main question is how these satellites have managed to reach a significant point where they enable internet connectivity services in various ways, even in the most remote and challenging locations on our planet Earth. One of the most important satellite systems currently in active operation is Starlink, which was launched by the company Elon Musk and SpaceX. This system is a network of numerous small satellites located in low Earth orbit, approximately 550 kilometers above the Earth, providing global internet access in space. Of course, Elon Musk's company was not the first to be active in this field. The idea of using satellites for communications dates back to the 1960s and 1970s. The first communication satellites, like Telstar and Intelsat, were working on this subject. However, their focus was more on international television and telephone. In the 1990s, for the first time, companies like HughesNet and Viasat began offering satellite internet to regular consumers, albeit with low speeds and very high latency. Because those companies used geosynchronous orbit satellites located 36,000 kilometers above the Earth's surface. However, the Starlink project, launched by SpaceX, uses low Earth orbit satellites, known as LEO, which have less latency and higher speeds compared to traditional services. For your information, since these satellites are close to the Earth, they need to orbit the Earth very quickly to stay in orbit. Their speed is about 27,000 kilometers per hour, and it takes approximately 90 to 120 minutes to complete one full orbit around the Earth. But Starlink managed to create an incredibly massive and large scale, and deliver extremely fast and reliable internet to remote areas without existing infrastructure. This is what made its name quite popular. It's interesting to know that in Starlink there are over 4,500 satellites in a cluster called a mega constellation, which can significantly overcome the limitations of current internet. Even more interesting is that you can see the Starlink cluster satellites from some locations on Earth. This view can be quite fascinating because all the satellites move in a straight line. Now, you might wonder whether 500 kilometers above the Earth is considered part of a country's airspace or not. This is actually one of the hot topics in space law and international regulations. According to international laws, particularly the 1944 Chicago Convention, each country has full and exclusive sovereignty over its airspace. However, This law does not specify the exact altitude of the airspace boundary. Most countries unofficially consider the airspace boundary to be at an altitude of about 100 kilometers above the Earth's surface. Some refer to this boundary as the Kármán line, which is considered the boundary between the Earth's atmosphere and outer space. This line is regarded as the division between the Earth's atmosphere and outer space. Above this line, there isn't enough air for regular airplanes to fly, and only spacecraft or rockets can reach there. So what about 500 kilometers? This altitude is much higher than the boundaries of national airspace and officially enters outer space. According to the Outer Space Treaty of 1967, space is not part of any country's territory, meaning no country or company can claim ownership of space or impose restrictions. For this reason, Starlink satellites and other satellites move freely in orbits above the Earth without being subject to national airspace laws. Generally, above approximately 100 kilometers, we enter the space domain, and aerospace law governs it. Let's move on to how satellite internet actually works. Specifically, satellite internet, unlike cable or fiber optic internet, is transmitted and received via radio signals. This means data is sent from your device or computer. It is transferred via a modem to the satellite dish on your roof and then sent to the satellite in space. After that, these same signals go from the satellites to ground stations known as Network Operations Centers, or ISPs, and finally return to your satellite dish on the ground and are sent to your device. However, although satellite internet is always connected, meaning you can have internet wherever you go without needing phone lines or other cables, it also has disadvantages. For example, satellite internet has high costs and significant latency, or it is slower and more expensive than DSL or cable internet. Well, let's delve a bit deeper into this topic. When we say satellite internet has significant latency, we mean the delay in time it takes for the signal to travel from the Earth to the satellite and back. The reason for this is that satellites are at a great distance from the Earth's surface, and this distance causes data transmission to be accompanied by considerable delay. This becomes problematic for activities that require quick responses, such as online gaming, currency and stock trading, or even video calls and online conferences. On the other hand, the speed of satellite internet also depends on other factors like weather conditions, which significantly affect its performance. Therefore, these delays must be considered for commercial use. Additionally, bandwidth limitations are another challenge of satellite internet. Satellites, due to their limited capacity, cannot process a large volume of data simultaneously. This results in internet speeds in areas using satellite internet typically being lower than in other regions that use undersea cables and fiber optics. However, despite these challenges, satellites still remain the only option for internet connectivity in areas where no other access is available. Let me also tell you that satellite phones and Starlink are very different from each other. Both use satellites, but their purpose, technology, and operation are completely different. Before satellite internet came along, satellite phones were quite common and suitable for remote locations like the sea, desert, forested areas, or anywhere regular mobile phones couldn't get a signal. The interesting part is that you must hold the phone's antenna towards the sky to have a direct line of sight to the satellite. Now, many people think that only Starlink is providing satellite internet. However, there is another company called OneWeb that is doing this with the support of the British government. Of course, Starlink's internet reaches the consumer directly, but OneWeb has a B2B system. This means it provides it to mobile operators, government companies, and service providers. Currently, the number of Starlink satellites is over 5,000, but the overall plan is for more than 12,000 satellites. However, in its first phase, OneWeb plans to place 650 satellites in orbit. Additionally, Starlink's geographical focus is first on America, then Europe, and then the rest of the world. However, OneWeb has focused on the North Pole, rural areas, and developing countries. The advantage is that both of these use satellites that are much closer to Earth, about 30 times closer than geostationary satellites, which are in Earth's orbit. This shorter distance results in a much more stable and seamless internet connection. The way internet is provided through the OneWeb satellite system is such that your device connects to a special terminal, which is the size of a small portable suitcase. This terminal encrypts the data and sends it to the satellites. It's important to know that although these satellites are small, roughly the size of a small washing machine, they still have very high processing power. In summary, the satellites send the data to the nearest ground station, where the connection to the main internet is established. But the surprising thing is that this entire process you saw takes less than 1/10 of a second. Additionally, since these satellites are constantly moving in a specific orbit, they create a seamless coverage. The coverage of each satellite is as large as a very big area like Alaska. So even in remote areas, at borders, in the middle of the ocean, at high altitudes, and in hard-to-reach places, it connects you to locations that are otherwise inaccessible, ensuring the internet is always available to you. On the other hand, traditional satellites, which are used for maritime and aerial communications, play a very important role in satellite internet connectivity. The VSAT satellite system stands for Very Small Aperture Terminal, which means a terminal with a very small dish that is installed with an antenna on the roof of airplanes. The airplane connects to the GEO satellite, which we talked about earlier, and receives the internet from there. Then, the internet is distributed as Wi-Fi among passengers in the airplane cabin. However, for example, Qatar Airways does not use this system. Modern flights usually use the LEO system, meaning they get their services either from Starlink or OneWeb. An incredibly interesting point about satellites is that they not only deliver internet to remote areas, but can also be used for scientific research and advancements in a variety of fields. For example, satellites allow scientists to easily and efficiently study weather conditions and climate changes, and even collect data related to deforestation and environmental changes. However, in this context, many questions arise. Can satellite-based internet one day replace the internet reliant on undersea cables? Will this technology advance to the point where issues of latency and bandwidth limitations are resolved? Currently, these questions remain unanswered. But what is clear is that satellites will play a crucial role in the future of the internet. Especially in today's world, where the need for digital communications has significantly increased, satellites are capable of providing global communications on a massive scale. What is your opinion about the future of satellite internet? Can this technology become a real replacement for cable internet? Or does it still need a lot of maturity and development? Be sure to write your thoughts in the comments. If you haven't liked the video so far, go ahead and hit the like button now, and also turn on the channel notifications to stay updated on the exciting upcoming videos. In summary, satellites have shown that they can play a vital role in establishing internet communications in remote areas. This technology, despite issues like latency and bandwidth limitations, is still advancing and might bring about a major transformation in the world of the internet in the near future. The very important lesson to be learned from this story is that no matter how many challenges new technologies face, there is always indeed a new solution to overcome the problems. Remember that the world is constantly changing and nothing is impossible.